This conference will now be recorded.
Today we will be seeing what is threads. We have seen what is class, what is function. We will today see what is threads and what is multi-threading, what is synchronization in Python. So before we go into thread, we just have to understand what is to understand multi-thread, you have to understand thread. To understand thread, you have to understand process and multiprocessing. So, what is process in Python? So, instead of talking about Python, what is process in general? So, let me open my task manager. So, this is my task manager of my system, and you see processes. So, there are multiple processes running in my system. How many? There are multiple. They are running in independently. So this is not dependent on this, and you can see how much CPU and how much memory and how much disk space they are utilizing. And only the Google Chrome is utilizing some network because it's over the internet. The remaining are not using my network. They are like local. So this is the process. This is what the process is. So in general, so here it's asking for PID. PID. If I wanted to search for particular process, I have to give process ID, and then only that process will be displaying here instead of all the process. So here I don't know about the remaining process. Citrix workspace is a process I open, and now it's not open. I usually open this for my company and just go to meeting. And what else is there? The Google Chrome, I have opened it. Microsoft Edge, Windows Explorer, these are the things I have opened. The remaining are like inbuilt process. So let me close this. So here, if you have to define process in terms of words, I would say process is a instance of a computer program that is executing currently. So process has three basic component. One is an executable program. So Google Chrome is an executable program. It's kind of .exe. When I click, it launches and I can do certain task and action over it. GoToMeeting is a executable program, which means you have to install it, and wherever you are installed, you open that folder and you go and click on some executable file, and then it opens and you can use that particular program. Correct. So a process is an executable program, and there are some data which that program consume the program uses. Okay. So now let's see what is Python threading in Python. Thread is a entity within a process that can be scheduled for execution. So it's a entity which is residing inside a process, and it's the smallest unit of processing that can be performed in OS. So all these processes are running in my OS, right, on Windows. If I remove Windows from my system, I can't do anything, right? So on operating system, there are multiple processes, and inside a process there is a smallest entity called thread. So thread will have a sequence of instruction within a program. So what is sequence of instructions? So see, have a program, we write function. Function is nothing but a sequence of instruction we give the program, we give the system to execute, right? See, if this is a condition, go and execute this, and in a for loop we tell them how many times it has to be executed. Everything we define before, right? It's kind of an instruction we tell before. 1 minute. Okay, so so it's a sequence of instructions, and they thread each thread as a state called running, ready, waiting, starting, and done. So running means the thread is currently running, and ready means it is ready for execution, but it's waiting for that particular time to get run. And waiting means if you are running multiple process in your system and all your CPU and memory are consumed, there is no space in CPU or memory to allocate to a new process, then it will be in a waiting state or starting state. And done means it's done. The work is completed. Now you can kill the process, or the process will kill itself and uh, free up the CPU and memory space. Okay. So, so you can assume that thread is a subset of process, that each process will have one thread inside it. You can assume in that way. So here is a diagram. Maybe if I reduce the size, you can see the whole diagram. So here, this is what a process is and thread is and how they work. So here, you see here, this is a process, and each process will have its own memory limit. We will tell you should don't allow more than this much of memory to this particular process. Okay. So and then each process will have its own thread, right? And this is a thread, and a thread is having a details to which process they belong to. So it is telling a parent process pointer. This pointer will point to this process so that they are associated with each other. So the thread will know it running for this process. And there is a thread ID. Thread ID is nothing but a ID, a unique ID given for each thread in the system, so that if you want to go and modify something, I mean, if you want to go and stop the thread, you can do it only with the help of thread ID. It's kind of a name. And there is a thread state that is starting, done, and waiting, all those things. And there is a program counter, register set, and stack pointer. These are used to save your data, your program data. Like if you are creating a local variable, you have to assign it somewhere in the memory, right? And local variables are assigned somewhere. And you have other things, right? Address of a memory, and the value, each will be saved somewhere, right? So the stack contains all your local variable used under the particular lifetime. So the program counter here, the program counter is a register that stores the address of the instruction currently being executed by the thread. If a thread is executing some function and the function is also stored somewhere, the whole program is saved somewhere, right? So it shows the address. So whenever the process runs, it goes and calls that particular function. The function detail are given in this program counter. It holds the address, okay? And then thread state, and what else we have? We have register set. It is registers assigned to thread for computation. If you are doing some calculation, then here this calculation happens inside the thread. So let me put these all like theory stuff, guys. Like you will not enjoy this much, but you have to understand this for interview point of view. So we understood what the thread is because it's a part of process which is running in your system. Now, what is multi-thread? How come multi-thread can exist within one process? So, multi-thread can exist within one process. It's the ability of a process to execute multiple threads concurrently. If you are having multiple programs which are independent of each other, you can run them concurrently, parallelly. Okay. So, each thread contains its own register set and local variables, right? So, all the thread process shares global variable and the program code. So the global variable will be there inside the process, and all the local variable can is saved here. You can assume something like if your function is having, if your one single Python code is having multiple function and they have to be executed parallelly, then you can assume that your program is a process and all the functions. For example, if you have three functions and all three are running parallelly, they are not running one after another, they are running parallelly, then you can assume that it's a thread, three different thread inside your process, something like that. So I want to put one more diagram. So this is a process uh, which has only one thread. So it is having only one thread. Code is here, register, address, and all the local variable. Everything is here. Okay. So this is a multi-threaded process. This is an example where there are multi-thread, which you see there is one thread, this is second thread, and this is third thread. Here you see the code, data, and files are common for all three threads. So this is where you save all your global variable, and this is a local variable. So if a function sum is having a, that is saved here. Function multiplication will also have a variable a that will be saved here, something like that. So this is thread 1, thread 2 and thread 3. This is an example of multi-threading process. So why do we have multi-thread? Why do we need multi-thread? So threading is a way to run multiple thread concurrently. It's useful when you have to have tasks that can be performed independently, and you want to speed up your program by running them concurrently. If instead of running them in sequence, after A, after B, then after B, then C, if you have to do in that way, it is going to take, for example, each A, B and C is taking 2 minutes. It takes totally 6 minutes, right, one after the other. If you are running A, B and C parallelly, because they are independent anyway, they B doesn't need any data from A or C doesn't need any data from B. They are independent of each other, and you are running to all them concurrently. All will be executed within same 2 minutes, right? Because each will start at 0th minute and each will end at second minute. So it takes only 2 minutes instead of 6 minutes. So wherever it's possible, Python does that, executing it in concurrently so that it speed up your program and reduce the time. Okay. So yeah, I understood what is process, what is thread, but how can I instruct Python to run multiple thread? So this you do by a module called a thread. There is a module called inbuilt module called thread in Python, threading in Python. You just have to import it, and you can define multiple function, and you can start all the thread in a single go. So let me put a code here. So here I'm importing a module called threading, and then I create my own function, my function, and I have some logic inside it. Ignore this. And here you can see I created my thread. So how do I create my thread? From the threading. So threading is a class. If you're I'm creating an object, okay. So I'm creating my thread is equal to threading dot thread, and here I'm telling target is equal to my function. So here the argument is you have to give your function detail because you are running multiple functions parallelly. You have three functions and you are running all three parallelly. So here I'm telling target is equal to which function this thread has to run. So I'm telling this is the function I'm assigning that to this thread. Okay. So I'm just creating this object from this class. You all know how to create an object from class, right? Object name, class dot the function of the class. This is a function. So this function I have to use, and I'm telling target is equal to my function. Here, if I give object dot start, this is a function inside this class called threading. So whenever I create an object from a class, I can use all the functions residing inside that class, right? So here I'm telling start, which is to start the thread, and if I want the thread to finish, and then I can tell dot join, the thread is finished. Let me show another example. So here you see in this example you are seeing how to create your own thread and how to assign a function to the particular thread and how to start the thread, correct? So now I'll show how to create two thread in one single program and how to start them so that they run concurrently. See here you are running hello from thread 5 times, and then the finally you are printing the thread is finished. Okay. So here this is an example where you have multiple thread. So here again I'm importing a thread. I have print number. This is my function 1 and this is my function 2. Then here you see I'm creating thread 1 and thread 2 and I'm starting both of them and I'm joining them. I mean we are finishing it. So here you see here the target have mentioned print number. This is my function, okay, and here the target is that is a function. What is a function of what is a function it's go this thread is going to run. So here the target is print letters. I'm assigning this function here and assigning this function here. Since this function needs the argument, I'm just passing I have to give comma and then I'm passing the argument. You have to use args. This is always args, okay. If you want to pass something uh, I mean, if you want to pass some argument to this particular function, then you have to give comma, then r, and you have to give your argument. So here I need two argument. I'm passing both the argument. So then here what we are doing within the range, whatever range we give, we are printing the numbers and we are printing all A, B, C, D in character. Here there is no argument, just I'm printing it. So I'm showing two different functions so that you understand how to create a thread which has a function with argument and one function without argument. So we have both the example here and we are starting it. So here you would see this as run first and then this and thread got finished. But what happens in the background is both are running parallelly. Only just when it prints, it has to print one after another for us, right? There is no other way it can print parallelly. Even parallelly, it has to print one after another only will be displayed to you. But what happens in the background is the multiple thread run concurrently, okay, and then your CPU and the memory, the CPU is actually saved and memory is also shared and it executes faster. So that is a main advantage of thread. So when you have a program, when you have a lengthy program which is taking at least 20 minutes to run, you can implement multiple threads so that you can reduce the time. So that is only reason we are going for multi-threading. But there is little disadvantage in multi-threading. The problem is a multiple thread run in the system. For example, if thread 1 is running, it takes some CPU 20%. It runs, completes and frees up the CPU. It removes, it goes away so that the CPU is again back to 100% from 80%. From 100% it went to 80% because it gave 20% to thread 1. And then once the thread 1 is completed, it goes back to 100%, correct? But what happens if 5 threads are running? Each is taking 20%. So all the 100% are consumed. Now all the 5 threads are running and the available CPU is 0%, right? So if one more thread comes and asks for CPU for the processing, there is no CPU available to give to that thread. So this is the only disadvantage while you think about threading. Like you can multi-thread, but there is a limit. You cannot go beyond that limit. Otherwise, all the system CPU assigned by your application will be used and you will run out of CPU and memory. But if you use it carefully, threading can be very beneficial. It will speed up your system. So here, start is for starting the thread and join is to end the thread. If you want to end particular thread, you have to call join function. In order to stop the execution of the current program, then you have to use join method. So I want to explain the above program in the form of diagram. So here you see there is a function one called print number and print letter. There are two functions and you are starting this initially, then you are starting this. So this is how it happens in the background. So this is a main program and here you start your function 1 and after a few seconds immediately you are starting your function 2. So this particular time they are running parallelly. Initially, there is a delay because you are starting one after another, right? You are starting it, it started, then you are starting this. So there is an initial delay, but they are running parallelly so that you save time. Here, your time is saved. So here, I'm going to show how to get the process ID. Here we are going to use os.getPID function to get the ID of the current processor. So this program will tell you how to use Python's threading module to run two tasks concurrently. The main module initiates two threads, T1 and T2. Each is responsible for executing specific tasks. This will do some task. This will do another set of tasks. Right? They run in parallel, and the code provides information about the process ID and the thread name. You can capture the thread name and the process ID also. Okay. So the OS module. So here I'm importing OS module, which will give me the access to the process ID and the threading module to manage the thread and their execution. Okay. So if you have to get the process ID, you have to go for OS class. You have to import this module called OS. So here I'm doing the same thing, whatever we did here, creating a two function. So here I'm creating task 1 and task 2 and here I'm creating T1 thread 1 and I'm creating target is equal to task 1. I'm assigning which function it has to execute and I'm just giving a name which is actually not mandatory, it's an optional, but to show the name here I want to show what is a thread name, what is a function name, what is a process ID. I'm giving a name here. So I'm starting and joining. So let's get back into the function. So this is the task one. So I'm telling um, threading dot current thread. I'm taking the current thread and I'm taking the name of the current thread. So threading is a module. It has a function called current thread. We are calling that function. Each class has multiple functions, right? This inbuilt module has multiple function inside it. We initially saw dot thread and we also saw start and we saw join. These are the three function methods we saw before. Now the next one is current thread. So it has all the details of the current thread, the thread which is executing currently. So we are capturing name from it. Okay. We can capture name only from threading, but if you want to capture the process all runs in your system, right? There is a system, OS, it runs all the process and the process has thread inside it, right? So who will have the details of process? OS, because all the processes are running inside the OS. So I'm importing OS module and I'm taking get PID. Get PID is a function which will get you the process ID. What process it allocated at that particular time for that particular thread. Okay. Let me execute this. So here it is telling the ID of the process running is this one. So okay, so here it starts. ID of the process running the main program is, I'm getting the main program process ID, the whole program. Now you have this import all this, no? This, so some thread or some program is importing threading, importing OS and allocating some memory for this function, right? So that is a main program. I'm getting the process ID of the main program, which is displayed here, which is always a number, and the number of digit will might change. It might be 4 digit or 5 digit, but it's a random number. Once this program is completed, this number is deleted, killed. That's all. Then you cannot see this process ID. And then I'm the main thread. There is a main thread, right? The whole thread which has all these functions. So I'm just printing the main thread. It's printing as main thread, and I'm then the object is created T1. My thread 1 is created, thread 2 is created. I'm starting my thread 1 T1. Okay, so it goes here. What is T1? Task 1. It goes here. Then it prints task 1 assigned to a thread is T1. So it is getting the name. This is a name because we have given the name is equal to T1. So this name is captured here. Okay, and then again there is a process ID, and this is a task 2 thread 2, and again there is a process ID. So why does it has same process? 1 minute, let me open task manager. So there is a Google, and you see in the bracket you see 32, right? That is because you might have 32 window open, or 32 other thread are running in parallel. Inside bracket you see 32. But in here you see only one process, right? Under the process you see only one, but under it it has multiple thread, multiple Google Chromes are opened. Some are closed, so the CPU is 0 now, but there are some multiple thread running inside it. So, but each thread will come under this process, and they will have only one process ID. Okay, they all come under this parent, and the parent name is shared among all the thread, and thread will have its own name, that is thread name. So here you see the process ID is same for all the thread, the main program, thread 1, thread 2, but the name for each thread is different. Each thread has its own name. Guys, any doubts so far? So is it clear or is it confusing? Okay. Tilly, what about you? Tilly, Sam. Okay. Tilly, are you there? Tilly, are you there? So here I'm just showing in a diagrammatic way. So this is a main thread which is having thread 1 and thread 2. But all come under this big circle which is called process. So all come under this process. That is why the process ID is same for all this thread, main thread and thread 1 and thread 2. Okay, but each thread will have its own name so that we can distinguish among each thread T1 and T2. So Tilly, maybe I'll revise it again from the starting. So there is some process, there is some feature called threading. Each programming language has this called threading. The main advantage of threading is you can run multiple program parallelly. Okay, so usually what happens, you're having a big program and it has multiple functions. Okay, and they run one after another. So it starts from the main where you're getting an input from the user or something, and then it goes on. If you're calling a function, it goes on to that function and return back the output, it prints. Then you're calling another function, it goes on like one line after the other, it goes on and execute. For example, a program might take 30 minutes for execution. Okay, if you want to save time here, if you want to speed up your program, uh, they have introduced a concept called threading. So the people thought, okay, if a few things can be run in parallel, I can do it in parallel instead of sequential order, so that the time is saved, which means your program will be completed within less amount of time, right? Initially it took 30 minutes, but what I'm doing, there are six function inside it, I'm running all the functions parallelly. Now it might take only 5 to 10 minutes, not 30 minutes. So when the UI is loading to the user, it looks like the UR is loading much faster to the user, right? Because everything is run parallelly and it gives a result within the less amount of time. Okay, so that is why people have come up with a process called, come up with a feature called thread. So to understand thread, what is thread and process, this is an example I could show. So this is a process. Even if you can open multiple Google Chrome and do something parallelly and go and check your task manager, so this is the process, one of the process running in my system. So whatever is running, whatever is open and running here in Task Manager, whatever you see, right? Everything is a process. That's how the system system imagines. That's how this it happens in the system. Everything is a process. So this is a process. This is a process because all are executable files. All are different program. So this folder is displayed to me because somebody has written a code behind it, so that it will display in this way and this will have all this feature. This is nothing but a program, right? A code written by somebody, front end code, right? Along with the backend and database connection, all those things. So this is everything is a program, right? Everything is an executable file which are running. And here you see there are multiple process. Here I could see three process. So for example, if you are opening a Google Chrome browser and you are opening three different tab, I can open three different tab and I can search something, right? I can open Netflix in one and I can open YouTube in one. Everything are working parallelly. It's not that okay, the YouTube will think okay, let the Netflix get complete, let it load, and then I will load. It's not like that, right? Everything will be running parallelly. So that's what here we are trying to do. So in this, consider this Chrome as a process, and you can create multiple thread inside it and you can run it parallelly. So initially what I'll do Jupyter notebook, then I think okay, I want to download some movie. I want to download three movie one, movie two, and movie three. So here I go and open some website and I download here. Here I open and then what I do, okay, this got downloaded, let me download movie 2, then that is also downloaded, let me download movie 3. So this is one way, or I can open three tab parallelly and I can download one movie here, one movie here, one, so that the time is saved here. If your data network is good, then all three will be downloaded together, right? That's what we are trying to do in programming language. See here, this is a main program. Consider this as a browser, and here I'm downloading movie one. Once I opened this and typed everything and clicked on download, I opened one more tab. So it is taking some time, right? There is a delay, little delay, because after you open, you download, you see the process is started, download process started. Then you go to next tab 2, and you try to download the next movie. So this part is like shared. So the time is saved. This much of time is saved in each movie, right? Each movie download. So that's what we are trying to do with thread. That's all. It's very simple to make the program faster. That is only way. If you find some functions are independent, if they are dependent, you cannot run in parallel. If they are independent, you can run them in parallel. So for this, we have to create a thread. So they have created a concept called thread. Now you have to implement the thread in your program. If you feel that you want to run multiple function parallelly, then what you can do, you can create a thread for each function and then you can start them parallelly. So started immediately, you are starting the other so that both the thread run together. Okay, so that is what we are doing, implementing the process called threading and running them parallelly here by creating thread 1 and thread 2 and starting them on after other immediately. So to create a thread T1, you are making use of some class called thread, which is threading, which is created inside Python. This is an inbuilt, like how you use, we have seen multiple inbuilt classes, right? So this is one among them. You are using threading, and this is a function inside it. Here you are going to tell which function this thread is going to execute. So I am telling target is equal to task1. Task1 is my function. And I am giving a name to this particular thread. So this thread I am giving a name and I am telling which function it has to execute. Same thing we are doing with thread 2. So that's all we are doing it here. You have to import this module and then you have to create your thread and start them. Okay, and then you can end them. Then inside this thread, you have some function called current thread. This is for just for example, I'm just showing what is a thread name. Usually in your program, you will not need this. You just create a thread and run them parallelly. But if you want to debug, you feel that which thread is taking time, you want to find that, then you can go for this. You can take a current thread and the name of the thread so that you can print wherever you want, so to know for debugging purpose. And then you can, so all the thread is created inside the process, right? Thread 1 and thread 2, they are created inside this process. If you want to get the process detail, then I have to import os module and I have to call get pid. This will give me the process name. So in the background, whether you're creating a process, whether you're displaying or not, your program, while your program is saved into memory, there is a process created and a main thread is created. Main thread and process is always there in the background. It's, you do not know, that's all. It's always there. Now what I'm doing, I'm just displaying it, get the process ID. So without all this thread also, if I can remove all this, but I can just give process ID and I can run simple normal program. Even though I don't have any thread concept created inside my program, I'll get the process ID because every program is kind of a process which is running in your memory, in your CPU, in your system. Okay. So that's all we are doing it here. Did you get the overall idea, like what is threading, why we are doing multi-threading, how we are implementing it in our code? The coding part I'm not explaining in detail. I'm just copying and pasting. I'm not explaining each line because I know you can understand what is function. I know you can understand why we are importing it and how we are using it. If you want me to explain the program line by line, please let me know. I can do that. Because now I feel that you all guys are in the stage you can, whatever program I give, you can understand it by yourself. Guys, I just need 2 minutes break. My daughter has, she got up. I'll just go and be back. I'm back, guys. So now let's see what is synchronization. So synchronization in Python refers to coordination and control of access to shared resource among multiple thread. If you're having multiple thread and you have a variable which is shared among all the thread, which is a global variable, and it should be shared among all the thread, then the process which the coordination and control of this, like how each thread can share that particular um, shared object or shared variable, so that is called synchronization. So this is to avoid conflicts, to ensure that the operation are performed in predictable and orderly manner. If some variable u is common to all the thread and all the thread are using it, there might be a conflict because thread 1 might be trying to access thread 2 also will be trying at the same time, and there will be a confusion or conflict inside it. So for example, assume that there is a database, there is a student database, and whenever a new student joins the institution, I go and insert a record. Okay, and then whenever for example, there are two students, Sam and Tilly, and there is a counter where the person gets the fees and updates in the DB. Okay, there are two counter and two people are working parallelly, and Tilly and Sam both are going and paying their university fees. So now what happens? Both the counter person are trying to uh, update some column which is telling that paid something, the column which is called fees paid or non-paid, you are updating it to paid. Both are trying to access particular row parallelly, then a system will commit only one thing in one particular thing, right, one after another. So for example, if Sam is also getting update and Tilly is also getting update, there will be a conflict. So if they are happening at the same particular time, there are some I mean, there are some possibility that one is inserted and the other is not inserted. Okay, or if one person is trying to delete and other person is trying to update the same record. So one person is trying to delete and the other person is updating the same row, they are trying, both the people are doing, only one will be applied, right? So one will be missed out, correct, one will be missed out. So to avoid this confusion, you will be, what database will do, it will occur log. So if you are doing something, if update 1 is happening, update 1 will happen, then it will apply lock on it so that it never changes. Then after committing it, it applies the second update on top of it. So it does a lock So sometime what happen if multiple people are doing it parallelly, there will be an issue. It will the database will throw an issue. There is a lock occurred. Wait for the lock to be released. So that the other person will understand. Okay, there is a lock is going on parallel now currently. Let me give few seconds and then update mine. So this is a concept we have this is done by synchronization, which will just avoid the conflict. If a same resource is shared by three different people, there will be a conflict. To avoid it, there is something called synchronization. It's actually done based on thing called locking. It locks. So let's see one after another. So just to avoid the conflict during the during the access of shared resource, we use synchronization. The first thing you have to understand is lock. So there is a method called threading dot lock. So what happens if consider this as a global variable. So here I have some variable. Maybe it is a counter. I have C and I'm just incrementing it. So now target one goes and increment. Target 2 also tries to increment at the same time. If both happens parallelly, what will happen? It will only be one, but it should be two because this updates one time, this updates one time. It should be two, but it will be only one because both happen parallelly and only one time it got incremented. It's not one after another. So to avoid this, first when target tries to update this particular variable, it goes and locks it so that everybody else will know that somebody is accessing it. So let me wait. So it goes update, first it locks, update, and then release a lock. Now the target 2 can go and update it. So that's what I'm trying to do here. As usual, I'm importing threading, and then there is a global variable which is defined outside the function. I have named it as a shared variable. So here there is a lock called threading.lock. So I'm creating an object for threading.lock. This is a method, class and method, right? Threading is a class and lock is a method. I'm creating an object so that I can use it here. Okay. Now what I'm doing, I'm creating a function. Okay, and then here I am accessing the global variable. Okay, and then with lock I am updating the variable. So whenever I access some global variable which is outside the function, this is a global variable. Okay, so I whenever I wanted to update this, I'm telling with lock means I'm locking it, updating it. Once this is done, once this line is completed, the lock will automatically be released. Okay, so that anybody the other thread can access it and update it. Why are we locking? Because I don't want the other thread to update at the same time, because only one update will be there, the other update will be deleted, will not be applied, right? Only one thing will be applied if both are happening parallelly. So I am locking it, updating it, and I am releasing it. It's just like you have a Excel and shared Excel. Both of people are updating it, and Tilly is updating and saving it first. So whatever thing Sam has written inside the Excel, everything will be gone, right? Whatever he written, everything will be overwritten by whatever Tilly had saved, right? A shared Excel, if somebody is updating first, the other will be gone. Something like that. So you lock it so that it will be shown to Sam, or somebody is in lock. So he will have another copy, or locally he will save all the details somewhere else. So whenever the lock is released from the local, he can copy and put it inside the Excel and save it. He will work on a local copy instead directly on the Excel. So something similar. So here I'm locking, updating it, and then I'm releasing it. So what is happening? I have updated it 5 times because here I'm telling update it. So here I'm using that lambda function. I'm writing a function in a single line. Okay, I am telling for x in range 5. Do it 5 times. Call this modify shared variable. Call this function. Okay, I'm telling call this function, and this is a thread object created. So using this, I'm telling call this function 5 times, and then I'm running, then I'm starting it, and then I'm ending it. So 5 times it got updated. The final value of the shared variable is 5. Each time a lock is applied and then a lock is released later. Okay, then there are some more topics. I guess we can continue tomorrow because if I start, I cannot end that. It is going to take at least 20 minutes on that topic. So I'll stop it here. So here today we saw what is process and what is threads inside process, how to create multiple thread and run them parallelly. So when they are running parallelly, they will have some global variable, right? This is thread 1, thread 2, and thread 3. But this data is global for everybody. If all are trying to access, there might be a chance that this data is not updated properly, because one of the update might be missed. That is why we are going for something called synchronization, which will handle it well so that the global variable is updated in a correct way. So the one of the way is to acquire a lock. You are locking the variable, updating, and then you are releasing a lock. So that's what you are doing it here using during your multi-threading. Guys, any doubt so far? So if you feel that you want to rewatch the video, and later when you get any doubt, please ping me over WhatsApp. I will explain you over call if you need. So guys, if you don't have any doubt, we can wind up the session here. Thanks all. Bye.